Hello and welcome to this video, the introduction into chemical bonding, our first actual Chem 20 unit. So chemical bonding kind of continues with what we did in the Science 10 review unit, looking at compounds and what happens when compounds are formed. So scientists early on were trying to study how elements appear in nature. Do they appear as single elements by themselves? Do they bond with other elements? And they created these categories of chemical bonding that we'll be looking at. So first of all, metals. Metals generally are not found on their own unless they're a precious metal. Most of the time they combine with a non-metal to make an ionic compound. Now that ionic compound can be called an ore, and as we know, ionic compounds in their natural state are all solid. Metals, again, that exist on their own are called precious metals, like gold and silver. All metals are also solid at room temperature, with the exception of mercury. So there must be, when it comes to the state of a compound or an element, when their particles are really close together and vibrating slightly, they're solid. When they're free to move a little bit more, they're liquid. And when they're in their gas phase, they're really far apart. Okay? So solid, liquid, gas. We'll look at this a little bit more later on. But the spacing of the particles, the motion the particles have to do with how far can the atoms or the molecules spread apart from each other. Okay, so it has to do with the forces of attraction holding them together. So if something is solid at room temperature, that means there must be fairly high forces holding those molecules, keeping them from breaking free into liquid or even gas phase. So later on, there is a type of bonding in metals called metallic bonding. Metallic bonding is not when a metal bonds to another element. It's just when you have, well, I guess it could if it was an alloy, for example, but it could be just like a sheet of aluminum metal or a piece of copper wire. What is holding all those atoms together? And metallic bonding we will touch on later on in the course. Now, nonmetals usually combine together to make a molecular compound, and as we've reviewed before, molecular compounds can be solid, liquid, or gas. Again, it depends on the attractive forces holding those molecules together that we'll talk about later in the unit. The only elements that are found on their own for the most part, there's always exceptions, are noble gases. And we know noble gases are stable, they don't form compounds because their valence levels are filled. So this all has to do with filling the outer energy level. We called this before the octet rule, right? Everything wanting to have 8 electrons in its valence level. Most elements that we're going to deal with, their valence level is the second and third energy level, which hold 8 electrons. Okay, so they're going to either gain and lose electrons, making an ionic compound, or they're going to share electrons, which is what happens in a molecular compound. Okay, either way to fill their valence level. Now keep in mind that the elements hydrogen and helium only have electrons in the first energy level, so that level will hold 2 electrons max, whereas the other ones will hold 8. Okay, this is also a guideline. Like I said, there's lots of exceptions. This is just a very simplified beginning to bonding. Now, the valence electrons, if you remember, are the electrons in the outermost energy level. They're the only ones involved in bonding because the inner orbitals are all filled. To figure out how many valence electrons you have, the group number tells you. Okay, so for groups 1 and 2 of the periodic table, if it's group 1, it has 1 valence electron. Group 2 has 2. We skip the middle of the periodic table, the transition metals, and we skip over to group 13 to 18. Those are what we call the representative elements, the ones that generally follow these rules more clearly. You're going to ignore the 1 in front of group 13 to 18. So group 13 will have 3 valence electrons, group 18 will have 8. Okay? Now the period number tells you how many energy levels are occupied by electrons, but we are focusing on valence electrons in this unit to figure out where bonding needs to take place. If you have a transition metal, you do not look at the group number to figure out how many valence electrons it is losing, because the ion charge tells you how many it's losing. So iron with a 3+ started with 3 valence electrons, but then it lost them to have an ion charge of +3. And that's what we're going to look at today. We're going to focus on forming ionic compounds. So if you're asked to draw the electron dot diagram of an atom, we're basically trying to show, if I were to have an atom, how many valence electrons does it have? We show it with dots to try to look at that, okay? It's going to have the symbol of the element with dots representing the valence electrons. In each energy level, the valence electrons are arranged in pairs called orbitals, in what we call orbitals, okay? I'll explain that a little bit more as we move on. In order to draw the electron dot diagram for an atom, you're going to first of all look at what group number it's in to figure out its valence electrons, then draw dots around the symbol clockwise, starting at the top for a maximum of 4 dots, and then if you have more than 4, you go back and start pairing them up at the top again, okay? So for example, sodium. Sodium is in group 1, so it has 1 valence electron. Now I said start at the top and go around clockwise, but these electrons are constantly moving. So if you draw the 1 electron up there, or the 1 electron right there, or the 1 electron on the bottom, it really doesn't matter, okay? The placement of the electrons don't matter. But we're thinking of these orbitals as my element being a box, and there's 4 sides to the box. So when I place my electrons, I start by putting 1 on each side if I have 4. If I have more than 4, I go and I start pairing them up, okay? So that there's 2 on each side, giving our total 8 electrons, and that's actually what argon looks like. Argon is in group 18, so it has 1, 2, 3, 4, 5, 6, 7, 8. So all of the orbitals are filled. Okay, these are the orbitals. The orbital 1, 2, 3, 4. Think of it like sides to a box. Okay? Now back to sodium. So like I said, sodium has 1 valence electron. You can put it wherever you want. I usually just start at the top. Magnesium has 2. Now, I don't pair them up. I put 1 on 2 of the sides. Okay? Same with aluminum. It has 3. And silicon, being in group 14, has 4. Okay? So I place 1 on each side, so each orbital gets half filled first with 1 electron. Then if I have more than 4, now I fill my orbitals. So here on top, phosphorus has a full orbital and 3 half-filled orbitals. Okay? Sulfur, being in group 16, has 6. So there's 4, 5, 6, and chlorine has 7, being group 17. 1, 2, 3, 4, 5, 6, 7. Okay? Part of your assignment is to try drawing some of those, and I'll skip over that when we get to it. But as I said, when you have an orbital that is filled, it is called a lone pair. And when you have an orbital that is half filled, it is called a bonding electron. So if I look at oxygen, oxygen again was in group 16. These orbitals are unfilled, the purple ones. They have 1 electron in them. So when they have 1 electron, they're half full. And those electrons are now called bonding electrons. That's where electrons will form bonds in a molecular compound. Okay? A full orbital are the blue sides. Those are called lone pairs. Nothing shares those electrons. Those electrons do not need to be shared. They're already paired up and they are stable. Okay? The number of bonding electrons also tells us the bonding capacity. So oxygen's bonding capacity is 2. It can form 2 single bonds when we get into molecular compounds. We'll look at how that happens. For now, though, like I said, this is an assignment for you to try. If I were to really quickly pop the answers up so that you can see them, you could pause the video and try them on your own. But the one thing to note is how helium pairs up its electrons right away. rather than putting one on each side. Helium and hydrogen will both do this because they only have one orbital, since their electrons are in the first energy level and they can only hold 2 in that level, and that's max. So hydrogen and helium will only ever have 2 that pair up right away. Okay, hydrogen, of course, being atomic number 1, only has 1, but if it shares with another element, it will share to make a pair. Okay, helium has the pair it already needs, and that's it. It won't get any more electrons. Okay, so let's look at ionic compounds. Now, this, first of all, is the definition. Definitions are really important in Chem 20, and you have vocab lists to complete. An ionic bond is the electrostatic attraction between oppositely charged ions. Okay, so I have a cation coming from my metal and an anion from my nonmetal. There's this invisible attractive force between them, like magnets that make them stick to each other. Okay, so metals, as I said, they usually have 3 or fewer valence electrons, so they lose their electrons to become stable, and we call them cations. So for example, this is what sodium as an atom looks like. When it forms an ion, it gets rid of that 1 electron to have no electrons. I put square brackets around it and a positive symbol representing how many electrons it lost. So sodium loses 1, so it has a 1 plus charge. Remember, we don't show the 1 in chemistry. It's just plus, meaning 1 plus. So this is what a sodium atom looks like. This is what a sodium ion looks like. Okay? Nonmetals, on the other hand, have more than 4, so they gain electrons to become filled. So let's say we're looking at oxygen again. Oxygen was in group 16, so it had 6 valence electrons as an atom. As an ion, to become full, it needs 8. It's going to gain 2 to have a full 8, and you don't have to draw them as different colors. That's just to show you. Those are the 2 electrons they gained, and it now has a 2 negative charge. Remember, electrons are negative, so when you gain electrons, you become negative. When you lose electrons, you become positive. Okay? Now, these compounds are going to come together, these ions, are going to come together to make a compound. So the number of electrons lost by the metal must equal the number of electrons gained by the nonmetal. The net charge of the compound must be 0. You may need multiples of your metal or nonmetal to make the charge and the electron transfer balance. Okay, so we have some examples here that we'll look at. Sodium chloride, calcium fluoride, and iron oxide. This is your rough work that you're going to show. And you don't have to show it, but I'm going to show it. And then this is your final answer. So you can do the rough work in your head and go straight to the final answer, or you can do it like I am. Okay? So sodium chloride. Sodium has 1 valence electron, and chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay? I need to get rid of all the electrons from my metals so that they have none. I need to get a full 8 around my nonmetals, so they have to gain as many as it takes. So sodium has 1 to get rid of, and look at that, chlorine needs to gain 1. Okay? So what I'm going to do is basically erase that electron around the sodium so that my sodium now has no electrons, no dots, and a positive 1 charge because it lost an electron. And my chlorine now has 8 because it gained that 1 that the sodium gave away. So it now has 8 electrons. I put square brackets around it and put its charge of -1 because it gained an electron. Then I write the formula for my compound. This was an easy one. I just needed 1 sodium and 1 chlorine for them to become stable. Sodium had to lose 1 and chlorine had to gain 1. But let's look at examples where that doesn't happen. Let's say we have calcium fluoride. So calcium has 2 valence electrons, and fluoride, again being in group 17, has 7 valence electrons. So my fluoride needs to gain 1 electron to become stable. But calcium has 2 electrons to give away. So what happens? Another fluoride is going to come along. I guess before it's an ion, it would be called fluorine. And it's going to gain the second electron that calcium has to give away. So now my calcium has no more electrons. It lost 2, so its charge is 2+. And the fluorine, it took 2 fluorines for this to happen, and they each now have 8 electrons around them and a -1 charge because they gained 1 electron each. So my charge is now balanced, right? I have a total of 2 negative from my 2 fluorines, and that matches my calcium 2 positive. So my formula is 2 fluoride ions with 1 calcium ion. Now let's try another one. I'm going to have to erase this to make some space. We're going to try iron 3 oxide. Now iron is a transition metal. And so remember, for transition metals, you figure out how many valence electrons it has by looking at its ion charge. So iron has a charge of 3+ in this iron 3 oxide compound. So my iron will have 3 electrons. 1, 2, 3. Okay? My oxygen, we know, has 6 because it's in group 16. So this is where it gets a little tricky. Iron has 3 to give away, but my first oxygen can only accept 2. Then I need to bring in another oxygen with its 6 valence electrons. Iron will give its last electron away, but oxygen needs another one. So another iron with 3 electrons comes along. I can't change the number of valence electrons, which is why I need multiples. Okay? So iron can give its one at the top away to the last one that oxygen needs, but I still have 2 electrons to give away from the second iron, so a third oxygen comes along and transfers those electrons. And now everything is filled and everything has lost what it needed to. So it took 2 irons to lose 2 electrons each, 3 electrons each. That should be +3. 2 irons each lost 3 electrons. And my oxygens each gained 2 electrons from the 6 that they started with to have a 2 negative charge. And now I need to draw 3 oxygens that did that, right? It took 3 of them in order to transfer the electrons away from the iron. The 2 irons took 3 oxygens. So my formula is Fe2O3. Okay? And that is how we draw electron dot diagrams for ionic compounds. Now just a summary here. The metal is going to always have no electrons around them when they form an ion. The metal ion, or the cation, will have no electrons, so no dots. The nonmetal will have a full 8 dots. And the nonmetal ion again, which is called the anion, they have square brackets around each of them with their charge. So remember, when they lose, they become positive. When they gain electrons, they become negative. And again, the total positive have to equal the total negative charges. This was the assignment I had my students do from their textbook, but I also wrote it up here in case they didn't have their textbook. Thank you very much for watching this video.